All right, so here's our video walkthrough for lab 3. This is actually round 2. Zoom did not get my audio, so I'm going to double check that to make sure it's recording my audio. Yep, okay, we're good. Okay, so a few tips for this lab. This will be good since I know everything I'm doing. Video walkthroughs are a little bit different than class. They're nice because you can pause and rewind on stuff you get stuck on, and it's easier to see exactly what I'm doing in R. So I'll explain some of the things we've already been doing. As some of us are still learning the how-to of R, I'll explain some places we get stuck, and so some of this might be a review for you guys, which is good. So for starters, make sure you download these two files into the same folder, hopefully OneDrive, put them there, and open up your lab 3. So, oh man, this is already, yeah, okay, good. I was just making sure it's not the lab that I already did. Okay, so in this lab, we're going to be working with the statistical formats of reading data and handling data, mostly like storing them as a variable and accessing everything. And we're going to be learning to display numeric variables. So that's very interesting. So to start with, so that you have the same screen as I do, here's a tip. Make sure you have this little table of contents thing listed, and also go clear workspace. This sweeps all the variables clean so it looks the same as mine. And then what we're going to do, my son's waking up, I hope he can sleep. Firstly, make sure you have your data loaded in R. So to do that, we have to have already put our data in the same folder as our R file, or R markup file. Have you done this? Yes. If these two files are in the same location here from what you're working on, then you're good. Then you'll have no problems reading this data. Then you can read it in, you'll see your data over here. Notice it also is green when you read it. If for some reason you forgot to put this file here, pretend it's not there, and I run this, you'll get an error. It says cannot open connection. It's kind of mysterious, but this is the biggest error I've seen with people sometimes working on their code. If your file is stored in a different place, like maybe you just put it in downloads and you don't see it, you don't have your data file in the same place, you'll get that error. So here, let's make sure that loans file is back there and run that again. Okay, so now that we have our data, the first thing we're going to be doing is looking at one variable. So let's make a new code chunk. This is Command-Alt-I on Windows. It's also Command-Shift-I on Mac, or Control-Shift-I. And we're going to be looking at everything that we're accessing now is from this file here, loans. So we say loans to start with, and then to access something in it, notice there's all these variables. We'll say loans $sign. I could start typing interest rate. So this plots or prints out all the interest rates of our 50 loans. This is 1 through 8. The 9th loan is this one, 17th, that's what these numbers here mean, up to 50. And so first thing we can do, we've already practiced doing this, is finding the mean, variance, and standard deviation of our data. See if you can remember how to do this. So the formula for mean is mean, variance is var, and standard deviation is SD. And so for each of these, we're going to want to put this exact data in here. So I'll paste those in there like this so that it can find me the mean, variance, and standard deviation. That's how we access data and find these kinds of statistics from our data set. So that was kind of review. Applying it now to our data. Next, we're going to look at 2 ways to plot one-dimensional data, the histogram and the box plot. Now, These are nice. They tell us something about the data. I could say the mean is 11.57, the variance is 25.52, and the standard deviation, that tells us something about the data, but a picture tells us more even about the distribution. So here's what a histogram looks like. I need to fix this. It says histogram. Great. So here's our histogram. Let me explain what this is. Of interest rate. On the x-axis is interest rate. X is the horizontal axis. The y-axis is the frequency of the count, the number of observations, in this case the number of loans that fit into each category. So between 5 and 10 is about 26 loans. Between 10 and 15 is about 12, it looks like, and so on. So this tells us very descriptively where my data is distributed. So you can tell me what this shows you in your own words. What does this graphic tell you? And then next, you'll make your own histogram of an additional variable. So let me see if you can do that on your own. Here is my process for doing that last one, but good place to pause and try to do it on your own. So here is the code from before. Notice I'm copying the parts before and after so I get the whole code chunk. I'm going to paste this under the correct problem. Here I'm making my own histogram. So if I paste it correctly, I'll see the green arrow. If I forget that part, I'll start seeing some errors below. It's kind of confused. Or if I run this, what does it do? Yeah, it has some problems. It doesn't like it. So I got to leave that there. If I don't put that in, I also can't see the green arrow anyhow. So careful when you're cutting and pasting. Got to cut and paste the whole bit of code. And so next, I'm going to plot another variable, annual income. Could make sure we type it right by doing $ annual income. And I got to change this to annual income. And it's always good to leave a unit if there is one. And then I could say histogram of annual income. Let's make it blue. Ooh, there's a nice distribution. Tells us most people make between 50 and 100,000. All right. So that's a histogram. Next plot is a box plot. Here's what a box plot looks like. And I didn't really describe the code for this. The code for histogram is hist, and then you have in parentheses a bunch of stuff that tell R what to do. First thing you do is you put your data, but it's got to be numeric. If I put in one of the qualitative variables, like state, look what it says. Ho, X must be numeric. X is my data. So look, I put in something that wasn't numeric. You can't make a histogram of a qualitative variable. This is only for numeric. So same for box plot. We got our variable X equals, you don't have to say X equals, but that's what R thinks of when you put in the first variable. It calls it your data, your X variable. Your label, your color, and your title. So run it. Notice this is different than what looks like, different than what's in your textbook. In your textbook, we got like a horizontal plot. This one's vertical. I think horizontal looks nicer. So if we add horizontal equals true to this, we got our horizontal plot. Here's what's going on with the box plot. Here in the middle of the box plot is the median. That's the center of the data. The left edge of your box is the first quartile, the 25th percentile. This is where 25% of your data are below that point. Okay, so then we go to the right side of your plot. That's the third quartile, or the 75th percentile. That's where 75% of your data falls below that point. And so this box shows the middle 50% of your data, 25 to 75th percentile. And that's colored in. All right. So then what's going on outside the box? Here we got what are called whiskers, two whiskers. This whisker here extends a length that is 1.5 times the length of the box. So this from the first to third quartile, from the 25th to 75th percentile, is called the interquartile range. And this is 1.5 times that. So you see it's a little bit longer than that length. Okay, extends that length if there's data that's beyond it, in which case the data that's beyond that whisker is put in little circles. So we got two little data points that are outside that. Those are potential outliers. And we do the same on the other side, except for if there's no data below a point, we just stop the whisker there. So the lowest interest rate was like 5%. So we're stopping the whisker there. So there's no potential outliers that way. So, whoa. How many potential outliers does this graph show us for interest rate? I should say 2. All right, so now your task is to make a box plot of income. You can pause and try to do that, and then check yourself with my code. There's my plot. You can tell me how many outliers are there. That's part of this question. All right, so the last plot we're going to cover in this lab is two-dimensional plots when we're trying to compare two different variables. So here's a plot of, I'll first plot this and let you see what it looks like. Okay, here's loan amount versus interest rate. So the first thing to notice is that the interest rate is x. X is the horizontal axis. So whatever goes right here is the first variable. Then we say y is the loan amount for the y-axis. And then we got the labels. And then the title is loan amount versus interest rate. It's always y versus x. Notice the loan amount is the y versus interest rate. So that's the correct way to label a two-dimensional graph. One of the main things a two-dimensional graph or a scatter plot shows us is whether there's a relationship between two variables. They seem associated, scattered together. And so for this graph, does there appear to be association? This is kind of subjective, but I would say no, because it looks kind of random. There doesn't seem to be any clear pattern. That's not the case of some of the others. Let's see if we can find a graph with a relationship between two variables. So question 12, recreate figure 2.1. This is in your textbook, but it's also in your lab. So I put it here in the lab, this plot right here. Recreate that. How do we make that in R? So let's first copy paste our bit of code here. Oh, what I'm doing is I click here and I hit shift and I click at the end. That's a good way to accurately copy paste. You don't have to be dragging your mouse all over. Okay, so let's see if we can dissect this graph. Loan amount is the y-axis. So we could go back to our plot and say loan amount. Okay, that's the y amount. That's already what we want. Now let's look at x, total income. We got to change the x-axis to total income. Okay, so that's already the same plot as this one, but now make sure you can fix the variables to look the same. And then tell me, do you think there's an association for this? Does there appear to be a relationship? tell me that. And then lastly, make your own plot of 2 more variables and tell me if there's an association. That'll be your last task for this lab. All right, so I hope this was fun. Come to class with questions, anything you got stuck on with this lab, and we'll cover it on our next class.